Welcome to Demystifying Math. In this lesson, we're going to be discussing mathematical induction. We're going to begin by finding an expression to represent the apparent nth term of an arithmetic sequence. We have the sequence that starts with 6 and goes 10, 14, 18, and 22. If we want to find a formula to represent the terms of the sequence, we need to know what our common difference between the terms are. So if you go from 6 to 10, you're adding 4. From 10 to 14, you're adding 4, and so on. So our common difference between the terms is 4. You also need to know what the first term of the sequence is, which obviously in this case is 6. So now what we're going to do is use the formula to represent the terms of the sequence, which is a subscript n equals a1, the first term of the sequence, plus d, the common difference, times n minus 1, where n represents the term of the sequence. So for the first term, n would be 1, the output is 6. For the 10, it's the second term, so n is 2. 14 is the third term, so n would be 3. So we're going to plug in what we know. Our first term is 6, and our common difference, d, is 4. And then we distributed the 4 to the n and to the negative 1, and then simplified by combining like terms. So let's try it out. If we wanted to find the third term of the sequence, we would replace n with 3. And then we would have 4 times 3, which is 12, plus 2, which gives us 14, which is our third term. So now what we're going to do is rewrite our sequence as 6, 10, 14, 18, 22, and so on until we reach 4n plus 2. By rewriting it this way, we're saying that this is a finite sequence with n terms. So the first term of our sequence is 6, and the last term is 4n plus 2. The sum of a finite number of terms of an arithmetic sequence can be found by using the formula s subscript n equals n over 2 times the first term plus the last term. For this particular example, the first term is 6, and the last term is 4n plus 2. So we replace those values in the formula. And then we're simplifying by combining like terms, and we get 4n plus 8. Then I distributed the 1/2, or divided each of those terms by 2, and got 2n plus 4 times n as a formula for the sum of n terms. Okay, let's see if the formula works for the first term. Our first term is 6, so our output should be 6. Our input value is 1 because we're only adding together one term. So we have 1 times 2 times 1 plus 4, which gives us 6. Let's see if it also works for the first two terms. So our first two terms are 6 and 10, so our output should be 16. So replacing m with 2, we have 2 times 2 plus 4 in parentheses, which gives us 8 times 2, which is 16. So it works for two terms. You can check and see if it works for more terms, but we're going to go ahead and look at what happens when we want to find n plus 1 terms. So far we just found n terms. If we wanted to add on another term beyond n, we would simply add 4 because our common difference is 4. So since our nth term is represented by 4n plus 2, our n plus 1 term should be 4n plus 6 by adding 4 to that. Another way that you can find that next term is to replace the n in the formula here with n plus 1. So it would be 4 times n plus 1 plus 2. And then distribute your 4 and combine your like terms, and again you get 4n plus 6 as your representation for your n plus 1 term. So now we have n plus 1 terms listed here. So our first term now is 6, and our last term is 4n plus 6. Now what we want to do is find the sum of all these terms. If you want to find the sum of the n plus 1 terms, you could simply take the sum of n terms and add the value of the n plus 1 term. So Sn represents the sum of n terms. Our next term has a value of 4n plus 6 on it. So we're going to take n times 2n plus 4, which we used to find the formula for the sum of n terms, and add on 4n plus 6. And then we're going to simplify that. So it's 2n squared plus 4n by distributing the n, and then add another 4n plus 6. And then combine like terms, and we get 2n squared plus 8n plus 6. You can also replace n with n plus 1 terms, with n plus 1 rather, in the sum formula. So here was our original sum formula for n terms. We're going to find the sum of n plus 1 terms by replacing n with n plus 1. So everywhere we have an n in the original sum formula, we're going to substitute n plus 1. Then I'm just simplifying inside this parentheses here. So I have 2n plus 2 plus 4, which is 2n plus 6. And then we have this formula for n plus 1 terms, the sum of n plus 1 terms. So we're going to FOIL that out and then combine like terms. And notice that we get the same answer that we had up here. So that's our formula for n plus 1 terms. Now what we're going to do is use mathematical induction to prove what we just showed. To prove that the sum of n terms is n times 2n plus 4. We're going to do that by first starting off by showing that it works for the first term. So we have S1 is equal to n times 2n plus 4, and replace n with 1. So we get 6. Now we want to show that it works, or we want to actually assume that it works for k terms. So we're going to go through and replace n with k. So we have k times 2k plus 4 is our sum. Now what we want to do is show that it works for the next term after k. So the first thing that you need to do is to be able to figure out what is that k plus 1 term. So we're going to replace k with k plus 1 in the formula. So we have 4k plus 6 as our next term. So what we're going to do is add 4k plus 6 to both sides of the sum formula. Now the other way that we can do it is to replace k with k plus 1 in the sum formula. So our sum formula is k times 2k plus 4. So where we have a k, we're going to rewrite it as k plus 1. And we get k plus 1 times 2k plus 6. Now we want to do is show that this formula for the sum is the same as this formula by adding the next term to the sum of k terms. Now we're going to show that they are equal by distributing it out. So we FOILed everything out just like we had done earlier, but in terms of n earlier. And we did the same thing for this one, and notice that we get the same answer. So this tells us that this formula works for k plus 1 terms, so that's the sum of k plus 1 terms. We also already showed that the formula works for the first term. So let's say that k was 1. Then we would say that k plus 1 is 2. So this means that it works for the first term, and it's working for the k plus 1 term, which is the second term. And then we could make k be 2, and it would be working for the third term. And then we could go through and make k be 4, and it will work for the fifth term, and so on and so on. So it's going to work for all of the terms. And it's kind of like a domino effect. It's like it's working for the first one, and then we can show that it works for the next one, which is the second one, and so on, until we've reached all the way to n terms. So that tells us that this formula is going to work for all positive integer values of n. Okay, thank you for tuning in to Demystifying Math.